Hello guys, good evening. Welcome to the online class. See, in the last class, we have completed the hydraulic formula which are to be used to determine the velocity. Okay. Now today we are going to see that what are the empirical formula or hydraulic formula are to be used in the determination of Q. See, this is actually this chapter is concerned to design of sievers. Okay, this chapter is concerned to design of sievers. So design of sievers means we need actually area, velocity and discharge. So you know the general formula of the Q is equal to of the discharge, Q is equal to AV. So that these three parameters are very important. In the last class we have completed the velocity determination using several formula. Okay, see that velocity can be determined. See Chase's formula, okay, Bazin's formula, Cooter's formula and Manning's formula, and as well as Krim's and Burgess formula. See, try to remember all these equations, okay. See, Eason's and also Eason and Williams formula, okay. Try to remember all these equations to determine how the velocity can be known, okay, from this. See, after knowing the V velocity, that is the velocity, okay, we have to determine the Q value. Q value already in the last class means in previous classes, that is DWF and WWF, that is in module number 1. See, we are knowing that the many types of the equations which are developed. See, and those equations are I was given already in the notes. That is Berkeley's Ziegler's formula, and another one is McMath's formula, Metcalfe and Eddy formula, and then Fanning's formula, Dickens formula, Rive's formula, English formula. See, these are all are used. This is hydraulic formula or empirical formula. See, these formulas are used to determine the Q value. See, the Q is ultimately what actually the discharge. See, now today we will start with the new topic under your syllabus. That is under your module number 2. So the second topic is velocities. Study on velocities. Now this is today class is 12th class. Okay. See, self-cleaning velocity, non-covering velocity, or minimum velocity or maximum velocity. Let us start with the velocity. See, the basic definition of velocity. What is the unit of velocity? You tell me. See, that is a meter per second. That means meter is the distance, that is single dimension. See, observe here, any units, suppose meter square means 2 dimension. 2 dimension means area, remember it. The single dimension is distance. Okay, so and then 3 dimensions means length into breadth into depth, that is a volume. You always you can judge very easily whether it is single dimension, second dimension, that is, or third dimension equations. Okay, see now the velocity. What is the unit of velocity? Meter per second. Meter is the distance and second is the time. Distance traveled with respect to time taken is nothing but a velocity. Okay, try to understand very clearly. Now we have to study in this chapter what you call velocities. See, there are two types of velocities we are going to consider in this chapter and this topic. If you know the velocity, how to determine this velocity, so that it will be very easy. See, now according to your velocity, see, one is the minimum velocity is required and the maximum velocity required. These two are very important. Remember it. Okay. See, now I will tell you what is the difference between the water and wastewater. I will tell you what is the difference between water and wastewater. In the last semester, the water supply engineering you have studied. Now this semester is municipal wastewater engineering, right? Now the wastewater and water, what is the difference between these two? Water is nothing but a clear substance, that means clear one, see, which is free from all solids. Solids means either settleable solids or suspended solids. Okay, see, this water is free from all solids and it is a pure in the form. It is a transparent, you can see. Okay, now this water, if you supply to the water to the public, they need a head. Now, hello guys, sorry for the interference. Okay, we are discussing on what you call water and wastewater. What is the difference between water and wastewater? Because the water is free from all the impurities, is a transparent, crystal clear. Okay, that we are going to supply to the public. But along with this, the before supplying to the public, you have to think about the head. See, the head is one of the factor, important factor. Otherwise, you won't get in the tap. The consumer point. That is what we are going to do is we are going to construct a overhead tanks. See, public overhead tanks, or in your house you have to provide one syntax tanks or concrete, that is RCC tank you have to provide. Through that you are getting the water, because the pipelines are, there are different what you call, the pipelines are turning points are so many, and this water can getting anywhere in your building. Wherever you take that pipeline, it will be reaching to the consumer point. See, since it is what you call having a head, sufficient head, so that the water will move from one place to other place. But in wastewater, you are producing the wastewater, finally it goes to the drainage. The drainage, from the drainage the flow will starts. Okay, that will go to where? Actually on the downstream side of the city or a town. See, finally will reach to the sewage treatment plant. Remember it, that is a treatment plant. Treatment plant will be always to be located, always to be constructed on the downstream side of the city. On the downstream side of the city. Understood? Remember it. Water supply engineering, that is the treatment plant of water treatment plant should be on upstream side, and wastewater treatment plant on the downstream side. These two are very, very important. See, the wastewater generated from your house, okay, the wastewater which is generated from your house, it has to reach to the sewage treatment plant in a particular time, because the traveling time is very, very important. Okay, see, the traveling time, it is within 1-2 hours. Okay, it has to reach to the sewage treatment plant, otherwise it will become septic. That we will discuss what is the meaning of septic and all, that is in the next chapter or next topic. Okay, see, now here we need a slope. What is slope? Some gradient is required to flow automatically by gravity without any head. See, for wastewater there is no head, remember it. Okay, wastewater there is no head, only the slope. What is the meaning of slope? Slope is horizontal is to vertical, horizontal and vertical values. See, h value horizontal is higher than the what you call vertical value. See, now using this, observe that what is a velocity, what is the unit of velocity? Velocity is a meter per second. Meter is the distance and the second is the time. Distance traveled with respect to time taken is called velocity. Those velocities you have to be what you call, we have to be studied in this chapter. Now this velocity, okay, why velocity is required? Because to increase the speed of the flow, to increase the speed of the flow. Otherwise the solids which are present in the pipeline, the solids which are present in this pipeline, see, they are going to settle. See, suspended and settleable particles are there in your wastewater. See, that is a sewage. See, the suspended particles, what happens? If it is a level ground, then automatically what happens? See, all the settleable particles is going to settle. When the settlement will be increases, the diameter goes on decreases. Then we need of some force to flush out that particular particles. That is why we need some gradient. If you provide more gradient, that is called, see, the flow will be increases. If you provide more gradient, what happens? If you provide less gradient, what happens? If it is a level, what happens? So the level means settlement of particles are more, increases, and it is a big problem. So that what happens? The sewage will come back, and it will be leakage will starts, and then through the manhole it will overflows. Please remember, this velocity is very, very important. Velocity means there are two types of velocity. One is minimum velocity you have to create in the pipeline to flush out the settleable particles. Okay, ಅದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇರಬೇಕದು. ಸಿ, ಅದರ್ವೈಸ್ ದರ್ ಇಸ್ ಅ ಪ್ರಾಬ್ಲಮ್. ಸೆಟ್ಲ್ಮೆಂಟ್ ಆಯಿತು ಅಂದರೆ ಇಮ್ಮಿಡಿಯೇಟಾಗಿ ಇನ್ಕ್ರೀಸ್ ಆಗಿಬಿಡ್ತದೆ, ಡೆಪ್ತ್ ವಿಲ್ ಬಿ ರೆಡ್ಯೂಸಸ್ ಆ್ಯಂಡ್ ದಿ ಸಿಲ್ಟ್ ಜಾಸ್ತಿ ಆಗಿಬಿಡ್ತದೆ. ದಟ್ ಈಸ್ ವೈ, ಸಿ, ದ ಮಿನಿಮಮ್ ವೆಲಾಸಿಟಿ ಆ್ಯಂಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೆಲಾಸಿಟಿ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಮೀನ್ಸ್ ವಾಟ್? ಫ್ಲಶ್ ಔಟ್. Minimum velocity, the particles should not settle, you have to, without any disturbance. You think it of one minute. So before starting this subject, I will tell you minimum velocity and maximum velocity both are very, very important. Minimum should not be less than the minimum value, and maximum should not be more than the minimum value. Like that, the gradient you have to provide for the pipelines, the sewer lines. Usually this wastewater contains, see, these are the what you call materials which are present in the sewage. See, the pebbles or small stones or gravel or sand or silt or clay. See, like this which are present in the sewage. What happens if these are present means the settling chances are more if you are not provided proper slope. Okay, then there is a big problem, maintenance problem. See, now this velocity means distance traveled with respect to time. I want to reach the target. I want to reach the point, that is sewage treatment plant, from starting point to the end point. What to do? See, now let us start with one by one. Okay, the minimum velocity means what? The another name for this minimum velocity is self-cleansing velocity. What is the meaning of this? It is, what is, once again, self-cleansing velocity. Cleaning and cleansing both are same, but the word we are going to use here is the minimum velocity is also called self-cleansing velocity. Self-cleansing means what? While flowing itself, it has to clean the pipeline. See, the self means automatic. See, automatic cleaning of the pipeline without struck, without coming back, without overflowing. See, this is called a self-cleansing velocity or minimum velocity you have to maintain. See, the short form is SCV. Okay, another velocity is called non-scouring velocity. Non-scouring means why we have to use this scouring. Observe here. Okay, this is also called maximum velocity. See, now non-scouring means what? The sewage consists of, already you are knowing that. Okay, see, so many materials, which are substances which are present in the form of small stones, angular stones, okay, and pebbles type, rounded, or silt, gravel, or sand, or anything, see, which are present in the wastewater. This will, if you provide more velocity, then what happens? These particles will damage the internal surface, inner surface of the pipeline. Slowly it is gone joining, because covering effect will be more if you provide more velocity. Velocity ಅಂದರೆ ಏನಪ್ಪ? ಸ್ಪೀಡ್. ಆ ಸ್ಪೀಡ್ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತದಲ್ಲ, ವಾಟರ್ ಫ್ಲೋ, the more higher the velocity, covering chances are more. Internal smooth surface of the pipeline will be damaged gradually. Then damage ಆದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? Small potholes will be formed, and then the solids will be struck there only. Then it is a big problem. Deposition of the solids will be increases. Then it will come back, and leakage and maintenance, it won't flow properly. See, just like a blood pressure in our body. Blood pressure means what? See, the pipelines which are carrying the blood in our body, it should be free from all the impurities. Impurities means cholesterol. Similar to the cholesterol deposition in your pipeline. See, the quantity is same. The quantity of wastewater is same. Quantity of blood is same in our body. It will move from, because pumping system is there. That is a flow, always flow. See, if the diameter is reduced because of the deposition, internal deposition, what happens? The pressure will be automatically increases. That pressure will be acting on your heart. Okay, like this here, the pressure which will be increases, and it will be, the wastewater will always trying to come out through the joints. That is infiltration and exfiltration. ನೋಡಿ, ಒಂದಕ್ಕೊಂದು ಲಿಂಕ್ ಇರ್ತದೆ. Please think it of yourself. Now, that is why these terminologies, see, what you call velocity and Q, these two are very, very important. Q can be determined using hydraulic formula. Velocity can be determined using many formula. Okay, see, now this is velocity. What is velocity? What is the meaning of this? That we will study one by one. Number one is self-cleansing velocity. The self-cleansing velocity means, just you study this one. It is also called minimum velocity. Silting of particles of solid matter present in sewage will settle in sewers if there is no sufficient slope of the sewer provided. If there is no proper slope or gradient of the pipeline, the silting of particles will be more and settlement is increases. That is why hence the sewer should be laid in such a gradient that a maximum velocity which will prevent the silting of particles in sewers is developed over a wide variation in discharging of sewage. Such a velocity, that is a minimum velocity, is known as self-cleansing velocity. Cleansing, cleansing. See, cleansing means cleaning. Self, okay. See, that is why they are given some values. See, for self-cleansing velocity, usually the self-cleansing velocity is 80 to 90 centimeter per second is to be maintained in the normal sewage. See, it will be depending upon type of wastewater. Okay. Now, for the sewage, you have to maintain 80 to 90 centimeter per second. Okay. Now, this is the standard table which contains the velocity value. Okay. Whenever it contains, these are the what you call the impurities or materials which are present in the sewage. For the angular stones ittu andre adralli you have to maintain 100 self cleansing velocity. You have to maintain self cleansing velocity should be in 100 centimeter per second. And if it is round pebbles 60, fine gravel 30, coarse sand 20, and then fine sand clay 15. See, these are the standard values to be maintained. And then this also depends upon, observe here, this is actually one is suspended. This depends upon this velocity, the self-cleansing velocity depends upon the nature of suspended solids or suspended matter in sewage and size of the sewer. Size means what? Diameter. If it is smaller diameter, the velocity will changes. If bigger diameter, velocity will change. That is why they are given with respect to the diameter of the sewer, the size of the sewer and velocity they are given. See, now here the diameter of the sewer is 15 to 30 centimeter. Suppose that is 15 means 150 mm to 300 mm. Size of the sewer is then self-cleansing velocity, minimum velocity you have to maintain 100. And it is 100 centimeter per second. Then 30 to 60 diameter, 70 diameter you have to maintain, that is 75. Okay. Then more than 60 centimeter, then 60 self-cleansing velocity you have to maintain. See, this is actually the velocity with respect to the diameter. This one is with respect to the materials present in the sewage. Remember it. Okay. Now let us go to the second one. See, the non-covering velocity or maximum velocity. See, this maximum velocity you have to maintain so that the flushing system will be constant and automatically the wastewater never be settled without any problem, without any troubles. See, it will move from one place to other place. Now, this is called maximum velocity. The maximum velocity is also very important in the design of sewers. If the velocity of flow exceeds a certain limit, the particles of solid matter in sewage, okay, starts damaging the smooth surface of the sewers. See, that is covering action takes place. The maximum permissible velocity at which no such covering action will occur, it should not take place, is known as non-covering velocity. Notice, self-cleansing velocity means self, okay, and the non-covering velocity means without damaging to the internal surface, the velocity should not be more than the standard values. That is why this is called maximum velocity, that is called what? Minimum velocity. Minimum and maximum, see, there is one end to other end, there is a boundary. Within that, the flow should be provided. That is why it's a trial and error basis. You have to be maintained. That is why the sanitary engineers are very, very important in the design of sewer lines. That is why slope is, we cannot provide more slope. If you provide more slope, the life of the pipeline will be reduces. If you provide less slope, it will, what happens? The siltage will be starts settling of all the particles. That is why, what is the meaning of self-cleansing velocity? This is self-cleansing velocity, and another one is what actually? The non-covering velocity. This, all the question papers, almost all the question papers, this question will be arises. See here, again, non-covering velocity you have to maintain with respect to what you call materials of the sewer. the what you call the sewer ಅಂದರೆ pipeline ಯಾವುದ್ರಲ್ಲಿ ಮಾಡಿದ್ದಾರೆ, that materials which are used, whether the cast iron pipe or steel pipes or RCC pipes, like that we are going to what you call give the standard values with respect to what you call materials of sewer. Okay, now here the sewer materials, if it is earthen channel, then non-scouring velocity 60 to 120, and then if it is brick lined sewers 150 to 240, then cement concrete sewers, see then 240 to 300, stoneware pipes, that is stoneware pipes SW pipes anta karitare. See these are municipal sewers, they are going to laid, it is around a half meter length, around 2 feet length of the pipeline. See here I will show you those pipelines afterwards. Okay, now here non-scouring velocity is 300 to 450 what you got centimeters per second you have to maintain. See the velocity you have to maintain in minimum velocity and maximum velocity in the design of sewers. These are very very important. Now see we are coming to the end of this one. In this topic only velocities and what is the significance are important you are going to study today. Now here the important factors to be considered for SCV and NSV. See observe here NSV and SCV. SCV means what? Self-cleansing velocity and non-scouring velocity in the design of sewers. What are the important factors to be considered? See these are the totally 4 points which are given. You by heart this one and they will ask this question, what are the factors to be considered in the design of sewers by using minimum velocity and maximum velocity, like that they are going to ask. So just I am going to read this and try to understand. Okay, in the design of sewers, okay, the discharge is known. In the design of sewers, discharge is known always. Okay, and hence the velocity of flow and gradient of the sewers are to be properly correlated to achieve the desired results. Please remember it. This is a slope. Okay, this is a h means horizontal distance L, and this is a vertical distance is called h. H by L is a slope or a gradient. Usually they will give in the problem. Using that you have to use Manning's formula or Cotter's formula or any other formula to be used in the design of sewers. Now, okay, next second point, in the flat country means a leveled ground, then what to do? See the flow cannot be achieved properly at that time. See that is why the maximum discharge you have to maintain. Okay, see the velocity of about 40 centimeter per second is to be maintained. See is at the time of minimum discharge. See if it is not possible to achieve this velocity, then flushing tanks are to be what you call provided to maintain the sewers clean. ನೋಡಿ ಯಾವಾಗಲೂ sewers clean ಇರಬೇಕು. Whenever zero discharge inside, the sewer should be very clean. Whenever the movement is there, at that time also it should be very clean and the flow should be continuous. See that is why these are the factors which are affecting on the what you call to be considered in the design of sewers by using velocity. See, okay, in a rough country, they are asking, third one is in a rough country, the sewers are to be designed to achieve non-scouring velocity. See, the rough country means a slope, too much slope. See, these undulations are so many. Then the maximum velocity should not cross its limit. Okay, and minimum velocity also should not be lower than the minimum velocity. See that maintenance is also very very important. What are these points? Tell me. These are the factors to be considered in the design of sewers by using velocity. See, without gradient it is highly impossible to take the wastewater from one end to other end. Is a must, because almost all sewers laid in the world, okay, anywhere, any location, remember it, this will go by gravity only. Most of the wastewater will go by gravity. Some of the places where there is no gradient, see, and at lower elevations to higher elevations you have to take, see, always you have to go by what you call, that is a pumping system. Now in your house, see, in front of your house there is a drainage, open drainage are so many. Okay, right side and left side, so Just I will give an example for you. And your road is always, see, in front of your house. See, that road should be always at a higher elevation, because whenever the rainfall occurs, that water should go to the shoulders ಅಂದರೆ ಓಪನ್ ಡ್ರೈನೇಜಿಗೆ ಅಲ್ಲಿ ಹೋಗ್ತದೆ, ಸೊ ದಟ್ ರನ್ ಆಫ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ಸ್ ಮೂವ್ಮೆಂಟ್. ಓಕೆ, ಯುವರ್ ಹೌಸ್ suppose it is lower than the road level, then how the wastewater is reaching to the drainage is very difficult task. That is why always before constructing, you are becoming, that means you are, as a civil engineer, you must know this technique. Your house should be higher level and road level should be lower level. Remember it. Your house, that is a first floor, should be always, it is a cellar. Suppose if it is lower than the road level, then it is a big problem. Then at that condition you have to go for pumping only, no other options. See, always pumping is costlier than the gravity flow. That is why the houses should be built. Don't take your sites at lower elevations. We are very, very, very important. Lower end of the city, if you take, means it is a big problem, because not only the floods, see, flood conditions, the first water will enter into your house only. See, like this here also, lower level and upper level, you have to see the drainage system. And house is below the road level, don't purchase, because we cannot lift your house, because roads are always increasing their height. Always, every year, while doing construction or maintenance, that level will be goes on increases. That is why always minimum 1 meter. I will prefer minimum 3 feet. 3 feet means 1 meter above the road level is always better. Otherwise, very big problem you have to face. See, now the third one is the rough country. Then what to do? See, rough country, what happens? The velocity cannot maintain properly. That is why the drop manholes are to be provided. Here, drop manholes are to be constructed along the sewer line, so that what happens? The velocity can be reduced. See, velocity of flow within the limits, we can bring that one. And next, the last factor to be considered. See, for combined sewers, it becomes difficult to achieve self-cleansing velocity at the time of minimum discharge. ನೋಡಿ, ಕಂಬೈನ್ಡ್ ಸಿವರೇಜ್ ಸಿಸ್ಟಮ್ ಇದ್ದಾಗ, ಅಂದರೆ Q1 + Q2 ಒಂದೇ ಪೈಪ್ಲೈನಲ್ಲಿ ಹೋಗ್ತದೆ ಅಂದರೆ, ಆವಾಗ ದ ಮಿನಿಮಮ್ ಡಿಸ್ಚಾರ್ಜ್ ಮೇಂಟೈನ್ ಮಾಡೋದು ತುಂಬ ಕಷ್ಟ ಆಗ್ತದೆ. ಸಿ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಸೀಸನಲ್ ವೈಸ್. ಸಿ, ದಟ್ ಈಸ್ ವೈ ದ ಸ್ಪೆಷಲ್ ಫಾರ್ಮ್ಸ್ ಆಫ್ ಸೀವರ್ಸ್ should be adopted to flush out the solid materials. Okay, I am going to stop at this stage. This is today what we are came to know, that velocities. Two types of velocities you have to study. One is minimum velocity and one is maximum velocity. And what are the standard values for with respect to that? See, for this also, see, what the minimum velocity, that means self-cleansing velocity, and this is non-scoring velocity. Otherwise, you cannot solve the problem so easily. And what are the factors to be considered in the design of sewers, using what you call SCV and NCV in the design of sewers? See, these 4 factors you have to remember. See, I will share you the notes, whatever I have completed as and today. See, I am going to share you. Please go through without wasting your time. Okay, thank you one and all. See, the next class I am going to take what you call design of sewers. Let us start with the problems. So, daily 2 problems. Don't miss the class compulsorily. You videos, whatever I have sent, see, you have to go through those videos at least twice in a day. Remember, you make a time and then go through those things. See, now shortly I am going to send the questions for these chapters. Okay, thank you very much.